So let's move forward to the next session. We've got a very beautiful session coming up right now. We'll have Champika on stage. Ah, okay. We have Champika is already here. So probably I can as well sit with you and take things forward. So right now we'll be discussing more on a technical topic. But before we start on what this technical topic is all about and how things work, I should first introduce you to the key resource person for this session, Mr. Champika. Champika is a tech guy. Okay, he did his master's in computer science. He works with the cybersecurity division of ICANN. And thank you so much, Champika, for flying down from Brisbane and spending your time with us and enlightening us on this key topic. Right through the day, you might have heard quite a few acronyms: DNS, TCP, IP, and a lot. Now, what are these acronyms? How do they work? Are they really important? Are three key questions which we might first have to take. So this acronym DNS, usually in networking terms, has quite a few full forms. Okay, I mean, we at times use it for a domain name system. At times we use it as a domain name server. And with a little bit of extensions, we might as well have heard about domain DNS sec, DNS security. Now, these terms, what are they? To start off, or to set the table, I'm sure we've all had at least one go through a phone book, right? And there is this back of the head knowledge that computers do not know English, or what a computer understands is numbers. But the human brain is not as good with numbers. And so you need something, kind of a phone book, which might help us associate names with numbers. Let that information be there. And with that pre-information, can you please let this audience know what is DNS? How does it work? And is it really important to have this domain name system in place? Over to you, Champika.
All right, thank you, Sabri, and also thank you very much, everyone, for joining this session. Now, to answer the question, I think we should go back to a little bit of history as well. I think this morning, Samiran started with how the internet started a long time ago, 40 plus years ago. And then there was TCP/IP. So TCP/IP has been the key protocol where we have been actually communicating the data communication over the internet. So TCP/IP, as you know, it stands for Transmission Control Protocol, and then the Internet Protocol. So when you think of the TCP/IP layers, you have 4 layers. Probably, if you have studied IT, you already know that. So we have physical layer at the bottom, and then we have the IP or the network layer, then we have the transport layer, and then we have the application layer on the top, right? So now, speaking of the data communication, as long as we have the addresses, the IP addresses, the packets can go from one place to the other place, right? But the thing is that, early days, of course, we had IP version 4 to basically give the addresses to all these hosts that, where we communicate each other. But then later on, we also started IPv6, like in late 1990s or around 2000 or so. And now the thing is that with these IP addresses, if as humans, if we are to actually remember these addresses, it's not going to be very practical, right? Even going back to historical days, IP version 4, that's a 32-bit number, so you have the 4 octets, and that we represent in decimals. But still, it's going to be very difficult. Even if I ask maybe some sysadmin, what's your web server IP address? Sometimes may not be able to tell straight away, right? It's not easy to remember. So from that perspective, I mean, as far as data communication is concerned, we can send the packets from one place to the other place as long as we have the IP address. But if we are taking from the human's perspective, because we are all humans, we will not be able to remember these IP addresses. So that is where we have to have some sort of a mapping so that we can remember something, right? So that's where we need a system, some sort of a naming convention where we can really remember these identifiers. So that's where the DNS really come from. Now, if you go back to historical days again, say 1970s and so on, it was pretty much a centralized database, right? If you are working in Unix and so on, you know that there is there's a file called host.txt file, right? So this was pretty much the database, right? So where we have, I mean, how the internet started, initially there were few, I mean, it was started as a defense project in the United States. And then later on, the academic institutions, they took over this project. And then few universities, few nodes got connected to this network, very early network. So all these nodes, they have to have a certain name and IP address. So Stanford Research Institute, they were having a node where they kept this host.txt file where you have references, where you have mappings between these names and the IP addresses of other nodes. So the problem is now when you have a centralized database like this, say, for example, if I am the one who is keeping that centralized file, and if you all are nodes, and then if you want to talk to any one of you, each other, you still have to first come to me because I'm the one who is keeping the file. So I'm the one who has to give the IP address of the other node so that you can go and talk to the other party. So now this sort of a system will have problems. What sort of problems is going to have? One thing is that single point of failure, because if I'm down, you will not be able to communicate because you can't get to me, right? So that single point of failure was a problem. And then there were other issues, things like the traffic, right? Because everyone trying to contact me, so definitely the traffic coming into me is going to be much higher as well. So traffic management is something very challenging. And then one of the other aspects was the name collision. So if I say give a certain name to one of the nodes, I can't give the same name to another party, right? Because otherwise there would be a name collision. So due to all these issues, having a centralized database or a file, we had to find some solution. So that is where, actually, some of the few names were mentioned earlier, some of the pioneers of the internet, Dr. John Postel, and also there was another researcher who was working with Dr. John Postel, that is Paul Mockapetris. So it was Paul Mockapetris who sort of came up with a solution for this problem, and that's where he actually wrote about the DNS, basically the new RFC, introducing this protocol, how we could get away from this centralized system of resolving into a proper kind of distributed system, and also more of a system where we could delegate part of your responsibility to another party or another server, so that everything doesn't have to stay in the same server itself, because earlier there were problems like single point of failure. So we could avoid this sort of situation, and that's where during early 1980s the DNS, the very first few RFCs are request for comments. So these RFCs came into the picture, and then the DNS was introduced. So now, it's a long answer that I gave, but it's taken like 40 years now. So DNS protocol has, we still have the DNS protocol, but then there have been quite a lot of enhancements, especially from a security point of view, because during early 1980s, 1983, when these early RFCs came, there was not much of priority was given to security, because the whole point was data communication, getting data from one place to another place. But then over the years now we have quite a lot of other enhancements, especially from a security perspective, where we have to actually implement those things as well. But now to come back to your question, so the DNS or the domain name system, this is how it started, and we have now come a long way. Still, the DNS protocol, it exists, and it will exist to the future as well. But the thing is that we have to consider several other factors, especially if you are to manage the DNS in the current form, because there are lots of challenges now when we have to manage DNS. So we need to actually work into all those aspects. So I hope that it answered.
Thank you so much. Now, I think one of the key aspects that we got through the day was that the internet was designed to work and not for security. Uh, Along with that, through the years, we've seen some drastic kind of changes in scalability as well. We've seen, or we've gone through an era where the number of devices connected to the internet have exponentially increased, and we've got the technological aspects being improved. New kinds of technologies coming in, especially the Internet of Things, and ultimately we might reach a day where this table and chair is connected to the internet. How do you see scalability on DNS? And I'm sure a little bit of the protocols were changed. We've got changes from IPv4 to IPv6. Did we really think ahead of a larger numbering system to come in? And has this changed in some way affected how the DNS works or how the system was designed earlier? What's your take on that?
Okay, now stop. Yeah, can you hear me? Yeah, all right. So from scalability point of view, DNS has been doing pretty well, actually. In fact, the design that I was talking about, right, from a centralized system to a more of a distributed system, that itself actually help the scalability, right? Because, as I said, we don't have to keep, DNS is all about databases, right? You're keeping a database. So one server does not need to be in a single server, right? The database need not to be in a single server, right? So you can always delegate components of this database to other servers as well. So this is where the whole concept of delegation comes in. Now, DNS is a hierarchical system, and so top of the hierarchy is what we call the root, right? And then we have the top level domains. When early days, when these top level domains were delegated, there were only very few of those, like 7 of those, like .com, .net, and so on. And there was a purpose behind that as well. .com was meant to be for commercial entities, and .net was meant to be for networks. .edu was meant to be for educational institutes. So there was a purpose, right? And then, so it's all coming back to scalability, right? So when the internet got expanded, more and more nodes got connected, and also actually the DNS got expanded, especially when the internet got went beyond US, and even the other networks in other countries also got connected to this whole network. So when the internet started growing, obviously the DNS space, the namespace was also growing, right? So from a scalability point of view, we were able to still delegate these namespace to different other servers. And this is where even things like country code top level domains got involved as well, because Earlier, there were only these legacy, the generic top-level domains. But then, when the other countries started having the internet, that's where the two-letter country codes, it was again an international standard, the ISO 3166 standard. Every country got two-letter country code, where, for example, like India, you have the IN and so on. So these namespaces were delegated as well, right, to different countries and so on. And then again from a scalability point of view, later on, I mean, there were some restrictions earlier, things like the generic top-level domains were only 3 characters, .com, .net, edu, and things like that. They were all 3 characters. But later, somewhere around 2000, these restrictions were gone, and then that's where we could have things like .travel or .info and so on, right? And then in more recent times, like after 2013 or so, the new generic top-level domains were also introduced. So these are, what I'm trying to say is that the namespace, it was growing all the time, right? Over the time, namespace was growing, and we were able to delegate to different other servers. So it was quite scalable. Even now, if you take the number of top-level domains, you have over 1,500 from original 7 to now it has grown up to about 1,500. So which means there hasn't been much of a problem in terms of scalability from a name server perspective. And then even from an operational perspective, things like the servers, having multiple name servers. There have been technologies like Anycast, for example. So when we have these sort of technologies, always it has been able to handle the aspect of scalability. So even when you think of the number of names, right, in some of the, if you take, say, for example, .com, right? So .com now has over 130 million names in the .com zone, right? So it has been scalable. So comparing to a centralized system with the current design of the distribution system, the hierarchical system as what we have today, it has been able to handle the scalability quite well. Yeah.
Thank you so much. So we are in safe zone as far as the DNS is concerned. And ladies and gentlemen, can I open the floor for a couple of questions on the existence on DNS? And probably you might have heard these terms on packet switching and all those things. So probably that's why we didn't go into the nitty-gritties of how DNS works. So if any of the audiences have, okay, I see two hands raised over there. Can some of the volunteers get the mic up there? Up there. So, ladies and gentlemen, let us keep the future part of the DNS aside. We are coming to that. So, we are currently on the historic perspective and the present status of DNS. So, please limit your questions to those areas.
My question is on the future, so maybe I can proceed
Okay,
with the
probably
question.
you'll have to wait for that.
Sure.
Yeah.
Same.
Same.
the
Okay.
future
So
part.
everybody is concerned about the future of DNS. So probably we can move forward. Are there any other hands raising? Yeah, there's one over here at this end.
So my question, I'm Rupam, and my question is about the IDN. So as we know, DNS resolvers work on the English Latin characters, right? But the IDNs usually have some Unicode characters in it, and they are converted into Punicodes. And what if like I use very similar characters that look similar in both of the domains, but the Punicode will be different? And what if one of them are legitimate IDN and the other one is a scam website? Like, what are we doing to tackling that?
Yeah, so you should take that.
I'm Rupam. I said.
Yeah, okay. to give everyone some sort of a background about that question as well. Now, from the early days that we have been talking about, the DNS was designed, the protocol, uh, the design was based on ASCII, right? The DNS queries, when we do the DNS query, it's all based on ASCII. And ASCII was the encoding scheme we used. But still, we use ASCII, right? Now, the thing is that when you use ASCII, you can only use very limited number of characters basically, right? If you think of the ASCII table, you're talking about 1 byte, so which is actually 8 bits essentially, and then with the if you put that into a table, you can only have 2 to the power of 7 values. You can't use that for 0. So which is 128, right? 2 to the power of 7. So which means essentially we can only have 127 characters in the ASCII table, ASCII encoding scheme. So when we use all the English alphabet and then the digits and so on, now by the way, actually before I go there, I also have to say that in the protocol itself, there are some certain rules. When you come up with these domain names, there are certain rules. When you think of a top-level domain, right? So the top-level domain, you can only have characters, the letters, right? You can only have letters. You cannot have digits. Say, you can have from A to Z, but you can't have things like 1, 2, 0, and all that stuff, right? So in the top-level domains. But when you think of second-level domains, you can have the letters. You can also have the digits, that is 0 to 9. And then you can also have the hyphen, right? Not other characters. In the keyboard, of course, you have all these other characters, star and all the other symbols, but we cannot use all that in the domain name. So we can use, this is what we call the LDH rule. So for second levels, we can have the letters, digits, and the hyphen. Now, so when you put all these characters into the ASCII table, pretty much the whole ASCII table is used, right? That's why, when you see your keyboard, you will have all those characters, and you can count all that, and we can fit that into the ASCII table. But the problem is when you try to bring in some non-ASCII character, right? Say, for example, one of, from India's perspective, if you take, say, Devanagari characters, right? Or, say, Tamil characters, or Kannada, or, your different character sets you have. So if you try to bring in those, there is no space in ASCII where we could actually use those, right? Because, ultimately we have to transmit the bits, right? The bit streams. So we have to convert these glyphs. These are all glyphs, right? So we have to convert these glyphs into a bit stream. So when we bring in all these other character sets, we cannot just use ASCII encoding scheme. So we have to come up with a different other encoding scheme. Now, there were a few other encoding schemes those days they came up with. And then especially the Unicode-based scheme. That's where the Unicode came into the picture, right? The Unicode. So you have the whole Unicode table where you can have lots and lots of characters in the Unicode. But the thing is again that we don't use all those Unicode character sets in the domain names as well. There are certain restrictions, just like what I said before. And so depending on the character sets, again, there were different encoding schemes. They introduced things like there is something called UTF. UTF stands for Unicode Transformation Format. Now, in UTF, there were different schemes as well. UTF-8, which is 8 bits, UTF-16, 16 bits, UTF-32, and so on, right? But the thing is that, say, for example, if you take UTF-32, you need like 4 bytes. So even to save or storage or transmit a single character, you need like 4 bytes to do that. which is just a waste. Sometimes, earlier we were doing it in 1 byte, but now you need like 4 bytes if you use UTF-32. So this is why it is very important for us to look at the backward compatibility. So we could still use ASCII, and then we can also use UTF as well. So it was kind of optimized. One of the most optimized scheme was the UTF-8, where we could have variable 8 bits of character sets, and then we could. That means, if say one of the English characters, we could still define that in ASCII, right? Because it is backward compatible. But if it is, say, one of the Devanagari characters, we could still use. It could be based on UTF-8. So this is where the whole concept of IDN comes into the picture, the internationalized domain names. So this is non-English characters or non-Latin characters you're talking about, right? Or in other way, I can say non-ASCII characters. So we have now two different encoding schemes we are talking about. One is ASCII and the other one is UTF-8. So if we are using local characters, scripts, then we have to use UTF-8. So until quite recent, right? So in 2003, there was one of the IETF standards that came, which is actually what we call the IDNA 2003 standard. IDNA means internationalized domain names for internationalized domain names in applications in 2003. And then later it was updated with a new RFC, which is IDNA 2008. So that's the standard what we use now for internationalized domain names. So now this is like sort of background that I'm trying to get to. So to answer your question, the DNS protocol itself, DNS does not understand all these Unicode characters or other glyphs. It only works, the resolution works based on the ASCII characters. So what if we are going to have, say, a string, Devanagari string? So in that case, we have to convert that string, or what we call a U label, because it's a Unicode label. So we need to convert this Unicode label into an ASCII label, right? So this conversion is what we call the Punicode. So you did mention about the Punicode. So Punicode is basically that Unicode conversion to the ASCII code, ASCII label, right? So if you are talking about DNS resolution, we have to do it based on ASCII, right? So whatever the local name, the local script, that string has to be converted into an ASCII string, and that is what we have to resolve, right? So we need to do that conversion as well, and this is where actually the whole concept of universal acceptance would also come into the picture. I think this is a big topic as well, universal acceptance, which means if we are going to have any software application, so this could be any application that runs has to now support these internationalized domain names. Not only the internationalized domain names, but also the email addresses as well, right? Because email address also has a domain name, part of our email address. So now earlier when I was talking about the evolution of internet, I was talking about the legacy generic top-level domains like .com and so on, the 3-character ones. And then later on I said, that restriction was gone. In more recent times, there have been some new generic top-level domains. That means any organized, now there are over 1,500 generic top-level domains. But the thing is that some software, some applications do not still recognize that. They only still recognize that old legacy top-level domains. So if, say, for example, if you are registering for this event, right? When you register for the event, if you have a, say, email address in Kannada characters, right? So if you have an email address in Kannada characters, and then if you give your email address into the web form, and if web form gives you an error saying that this is invalid email ID, this is where we say that that application is not universal acceptance ready or UA ready. So we have to fix these things. So the applications has to be fixed to make sure these new domain names has to be accepted. The longer domain names, the longer TLDs are accepted, not the legacy ones. And also the email IDs are accepted as well, whether it's a Tamil email ID or Kannada email ID or English email ID, anything, right? All those things, the IDNs are accepted. So all those things has to be fixed. So this is where the whole concept of universal acceptance also comes into the picture. And there are even, for example, some email IDs we write from right to left, like Arabic, for example, Arabic characters, Arabic. The language, the script we write from right to left, not from left to right. So if the application doesn't recognize that, then there's a problem, right? So we need to fix that. So anyway, to answer that question, in terms of DNS resolution, it's only going to work on ASCII. So if there is some if there are some U labels, that means the non-ASCII characters, those need to be converted to an ASCII character, ASCII stream, and then which is what we call the Punycode, and then the Punycode is the one that is going to actually do the resolution, right? And that's how the DNS queries would get resolved if it is an IDN. Hope that clears.
I'm sure that answers the question. Do you have a question?
So my name is Anita, and I have one question. So this is about the when you assign the CCTLDs. I'm curious to know knowing that AI actually emerged in 1960s itself with ELISA computer. So why Aguela was given .ai? So that's one of my questions. And also, Indian Ocean is not actually a place. So now .io is adopted so much by tech community. But why was it assigned? I'm just want to know what was the reason. Was it just human choice, or because it's a multi-stake thing, right?
Okay. Yeah. So the I mean, sorry. So in fact, actually, this morning Samiran was explaining about the IANA. IANA is the Internet Assigned Numbers Authority. I mean, very early days, of course, it was that Dr. John Postel, whom I was referring to earlier. He was the one who was, he's called the father of the Internet Registry System. So he was the one, if any organization needs IP blocks, or if they need some top-level domain, for example, it was John Postel who allocated that. But later on, this entity was created, the IANA, the Internet Assigned Numbers Authority, and this was created within the US government. And so IANA started delegating these country code top-level domains. So it was, as far as I know, there was no any AI aspect was used during that time. It was all about kind of the international, because there was an ISO standard for every country. You have a 2-character country code. So 3166, ISO 3166, and then based on that country code, based on that standard, different countries or the territories, they were delegated the CCTLD, and those days, of course, quite a lot of researchers who were involved in some countries, internet-related research. I'm talking like in 90s, right? So when they came up to John Postel and sort of convinced or justified that, okay, they're working on this stuff. So it was quite leniently delegated to those entities. Same with the IP blocks as well. Those days, there was these class A's, B's, and C's were just delegated just like that. And then many universities in the US, they got class A's. Some big corporates like IBM, for example, they got, big blocks. So all these internet resource management aspect was not there. To answer that, it was based on this standard. Those blocks those CCTLDs were delegated. But now, of course, the processes has all streamlined quite well. So there are all the policies and processes are in place. There are, in some places you need some redelegations. So those things, there are processes in place. So it's all quite streamlined now comparing to those days. Yeah.
There is the entire system working, and then there is the address resolution protocol working at the back end. We understood that it is scalable, and the scalability factor has not affected much the DNS, and ultimately it was not designed for security as well. So with all of these protocols and issues with IDNs coming in, where or what are the kind of common threats that you feel that the DNS is going to face, and how can we, or how do you think is a mitigation of these threats being done at this point of time?
Yeah, actually, just you mentioned about the threats. I forgot that I couldn't answer one of his points because he was talking about in local language the similar characters, right? So in say, I don't know, maybe in Kannada or Telugu, you have similar looking letters, especially when you look at even mobiles. Especially when you look at those characters in a small screen, you may not really recognize the difference, right? So this is a problem. So this is where, there can be quite a lot of DNS abuse that can happen, especially things like phishing sites and so on, if we don't take action against this. So this is where there are things called, if there are similar looking characters, we don't delegate those, right? Either you have to reserve. There is something called, it's called, if there are similar looking strings. So when you request for a domain name, say for example, right? So when you request for a domain name, if there are similar looking characters, you will see with another language script, we have to actually, we don't delegate that, right? So that is either that should be reserved or basically it should be blocked. So that would avoid, especially when it comes to the IDNs, that should avoid that DNS abuse possibility. So in fact, actually, even in many languages, you might find this issue. So we have already taken that. So this is where actually one of the job of the panels, because before really, again, I think I have to go back to some of these, how these working groups would work, because before we really make sure we decide on a certain script, whether how we are going to delegate that, we have to actually get the local expertise. Say from India's perspective, there are several language scripts, right? So there was a panel created called NBGP panel, Neo-Brahmi Generation Panel, number of years ago. So all these experts who are, or the linguists, and all the experts who are experts of the language, they got together. Then they would analyze every different script and see, okay, are there any similar looking characters? Should we bring in should we delegate domain names in these? Are there going to be some similar looking issues? So those kind of things have been looked in, and then the rules have been developed so that in case if two parties request, even one party request for a certain script with that sort of a character, then the similar looking character would be blocked, right? So that has been taken and it has been built onto that rule set. So when you request for ID and domain, you will not get that sort of a similar looking character, right? Now coming back to the other abuse related matter, the security matter. Now earlier I told you that the original DNS protocol itself didn't have much of security built into the protocol. So later on, we saw that there were quite a lot of issues, especially things like cache poisoning, right? Wrong answers could go into DNS caches, and then the clients could be taken into wrong websites, phishing websites, and so on. So there were DNS hijacks. For example, when you go out and connect to public Wi-Fi networks, or all these public networks, you are using someone else's infrastructure or resolvers. So then they could give you wrong answers. Say, for example, some attacker could run a public network, say, free Wi-Fi network, for example, in a public place. And then if you get connected to that, your DNS queries would be going through their infrastructure, which means, their resolvers are giving you the answers. So if you want to visit your bank website, they could be giving a wrong answer for your bank web server IP address, so that you would go and end up in a wrong web server, right? So those kind of issues came in. And then there were quite a lot of other issues as well. So this is where quite a lot of security standards were built on top of that. Now, DNS security extensions. So this was a standard that came later on. Simply, we call it as DNSSEC, or simply, that's what the term says. DNSSEC, DNS security extensions, that was built on. So nowadays, DNSSEC is kind of a must, actually. So if you are running, especially if you are running some critical zone, if you are running some critical DNS servers, deployment of DNSSEC is something very, very important. And at the same time, the public resolvers who would resolve DNS queries, they also have to actually validate these DNS queries and check whether these queries are really coming from the right source, and also whether they are not modified in the middle. So we have to handle the integrity aspect. We also have to handle the authenticity aspect. So we do this by using public key cryptography. And so this is where the security stuff is handled. So when it comes to the bottom line answer is that DNS protocol, as it is not secure. You have to have different security mechanisms on top of that to achieve more security. It is not just only the DNSSEC, but there are a lot of other standards as well. For example, if you need confidentiality, if you need privacy, there are protocols like DOT, DOH, and so on. So there are various other security mechanisms that we can build in on top of DNS.
Thank you. Thank you so much. So we understand that the security is an extension that was put on top of the DNS system. Now, and we are using a little bit of encryption to keep things as safe as possible, as we understand. With advancing technology like the emerging trends like artificial intelligence, this quantum computing, we heard a session on quantum computing yesterday. Do we see any threat to DNSSEC in the near future with these technologies coming up?
Now, the question was on the DNSSEC side and the future of that. DNSSEC has been there for many years, right? It has been there for near like 20 plus years now, right? So the thing is that first of all, I think, let me take a hands. How many of you are aware of DNSSEC? How many of you have heard about DNSSEC? All right, so there are half of the class who have not heard about DNSSEC. So as I said earlier, DNSSEC stands for DNS Security Extensions, right? Now, earlier I was telling one of the big problems in DNS is the DNS data protection. Say, for example, I'm a DNS server, right? I told you that earlier. I have to keep databases. I have to keep a DNS database about my records. Say, if I'm having a web server in my network, in my DNS database, I have my web server name is www, and my web server IP address is blah, 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 right? So I have a mapping. So similarly, all the hosts in my network, the mail servers, DNS servers, various other resource records that I have in my network. So I have all those mappings in my database. Now, the problem is, say if attacker somehow managed to get this data, say, one of these clients asked me, okay, give me the IP address of www.example.com, right? So ultimately, when I get this query, if I am managing example.com domain, right? If I'm managing example.com domain, I am the one who is going to give the IP address of www.example.com because it's in my database, right? So when I give this answer goes into a caching server somewhere in the middle, right? Maybe operated by some ISP or operated by a public resolver, right? So this answer goes and stays in a cache, right? Now, if some attacker managed to pollute that cache, right? So if I tell the IP address is 1.2.3.4, and if the attacker managed to pollute it to 3.4.5.6, ultimately client is going to get 3.4.5.6. So client might think my web server IP address is 3.4.5.6 and not 1.2.3.4, right? But I gave 1.2.3.4. So client is going to a wrong website, right? And then that website looks exactly like my website, but it may not be the right website. So this is a typical cache poisoning type of attack, right? So in such situation, how do we make sure client gets the right answer, right? That is what we have to make sure. So we have to achieve two things to do that. One is authenticity. What do you mean by authenticity? Authenticity means, is this answer really given by me? Is this answer 1.2.3.4, is it really coming from me? Because I am the one who is authorized for that data. So this is one question. And the other thing is, when I give this 1.2.3.4, is this data modified in the middle, right? If someone managed to modify that to 3.4.5.6 in the middle, that means client is going to get some wrong answer, right? So we have to make sure, so this is what we call the integrity, as you know, right? So this is integrity. So we have to make sure when we deal with DNS data, the integrity is protected, the authenticity is protected. Are we getting the right data from the right place? Are we getting the data which is not modified, right? So this is what we are trying to achieve in DNS, using DNSSEC, right? So using these DNS security extensions, we are trying to achieve this data is coming from the right place and this data is not modified in the middle. Now to do this, we use cryptography, right? We use asymmetric keys, for example, private keys and public keys. How do we do that? We actually, all those data what I have, all those records what I have in my database, I will sign this data using my keys, basically the private, I have the private key and the public key. So once I sign this, I will have signatures. And then when I publish those data in my database, I will publish together with my signatures. So when you request for those data, you're going to get the data together with my signatures, right? And then we have to have some mechanism, someone to validate whether this data is really coming from me, whether these signatures really belong to me, right? So this is all PKI stuff. And that's the whole concept of DNSSEC. So far, DNSSEC has been slowly, if you think of the statistics, it has been improving slowly, right? Even though I said 20 years plus, but if you look back, the things have, people have done quite well. Why I'm telling you? Mainly because earlier I was telling you that hierarchy before. So you have the root, you have the top level domains, you have the second level domains and so on. So from the root's perspective, the root database, the root has been signed, right? So whatever you are getting from the root is all signed, right? You can verify that data. And then also, if you consider the TLDs, the top level domains, 90% of the top level domains in the world, out of that 1,500 I was talking about, .com, .net, and so on, the top level domains, .in. If you take .in zone is signed, digitally signed. So if I ask .in servers, give me the name servers of .in, I get a response, and that response comes with the signatures, and I should be able to validate those signatures. So the top level domains, 90% of the top level domains has been signed. So we are, pretty good. Root has signed, 90% of the top level domains have signed. But when it comes to second level domains, we still have to do quite a lot of work worldwide. So globally, if you take the domains, only about less than 10% of the second level domains have been signed or deployed DNSSEC. So this is why actually, especially if there are organizations, if you represent any organization, it is something to think about. Why earlier, you had this cybersecurity role play, right? Many of these attacks come because DNS is a public-facing infrastructure. All our data is in public domain, right? Our web servers, mail servers, all these IP addresses, databases, right? It's all in the public domain. I mean, DNS is public. So you have to make sure that this data is protected, right? So using DNSSEC or protecting using DNSSEC is very, very important. So as I said, at the moment, less than 10% of the second level domains have been signed. So we have to make sure that organizations are aware about this and so that they can sign their zones. So this is the signing part. And the other aspect is the validation part. So who is doing the validation? Validation is done by the network operators, ISPs, mobile operators, and so on. So all your queries, like when you have internet at home, right, you are connected to an ISP. Your ISP or mobile operator has given you that connectivity. So most of your unless you use any public resolver, your queries are going through your ISP's DNS resolvers. So your ISP's resolver has to validate, before they really give an answer to you, they have to validate and say that I'm going to validate this answer and I'm going to give the correct answer to my client. Otherwise, if the ISP give you a wrong answer, you can end up in going into a malware site, right? So even from ISP's perspective, they have a responsibility. They look after their clients and they give right answers to their clients. Again, speaking of the future, we are talking about DNS and the future. So where we are heading is there are going to be, even among ISPs, who can give better service to their clients, to their customers, right? Ultimately, it will boil down to the competition as well. So if your ISP can give you a good service, you will go with that ISP. If your ISP is giving you a bad service, you will switch that and go to a different ISP. So from operators' point of view, if they are to give a good service to your client, they have to make sure they do DNSSEC validation, and so that they can protect the client, right? So anyway, the bottom line is DNSSEC is something very important. It has been slow. Why people have, or the organization, the operators have not been using DNSSEC that much, mainly because it's a bit complicated, right? Because you are dealing with the cryptography. You have to deal with the keys. You have to deal with the signatures. Say, for example, if your signatures expire, because signatures has got a certain validity. If your signatures get expire, then the resolver's not going to validate it. If the resolver is not going to validate, clients, they can't visit websites, right? So clients might complain the ISP saying that, I can't visit this social media site, or I can't visit my bank website. So this is why sometimes, the ISP is also a little bit skeptical, okay, should we really deploy DNSSEC? But the thing is, there is a cost versus risk. The same, the previous exercise you did, the role play, right? So you have to actually, there is a cost to achieve the security, right? And but the bottom line is, DNSSEC is something very important that you should be considering. And more, we see that in the last 5 years or so, the DNSSEC deployment has been growing in a very good rate, both the signing and the validation, which is a good sign actually. And we hope that even in the future, these rates going to be quite high as well. From India's point of view, DNSSEC validation is currently at the as a percentage, it's around 60%. So that means all the queries coming from India, about 60% of the DNS queries coming from India, they are going through DNSSEC validating resolvers. So only about 40% of the queries are not going through DNSSEC validating resolvers. So we can still improve. There is room for improvement. And also, as I said earlier, .in has signed DNSSEC, which means .in zone has signed. So if your organization has got any domain name from .in, say example.in, you can also deploy DNSSEC, and then you can propagate the trust to .in, which is a good news as well, because in some countries, their CCTLD has not deployed DNSSEC. So if the CCTLD has not deployed DNSSEC, then you can't do much, because for DNSSEC to work, you have to propagate the trust to your parent level. Okay, so that's the sort of status with the DNSSEC in terms of global as well as India's perspective.
Thank you so much. And now I'll take questions. We had 2 questions over there and 1 over here. So let's go to the first candidate there and then come back to you. The first lady over there. This side, the lady on the left, and then we'll come back to you. Over there. She was the first to raise her hand much earlier. Yeah.
Hello. Hello, sir. We met again. I met you in 2019 in Sanok.
Oh, okay.
You taught us DNSSEC back there. So I had a few questions. First one is, though DNSSEC provides us with the security enhancements, there are some challenges also, like performance issue and compatible issue in legacy systems, as well as key management challenges. So how do we as a network admin address those? Also, during DNS propagations, there is high chance of like system downtime issue there is. So how do we handle those?
Okay.
My name is
sure.
Aishwarya.
Okay, yeah, thank you.
Can we take this question as well? Because of time.
Hello.
Yeah.
So my question is more specific into a new policy that has been suggested back in Malaysia. So recently in September, the government of Malaysia, they just redirected for ISP. Basically, they changed the DNS in Malaysia in order for them to control whatever that can be displayed on the internet. So basically, they have more control over the internet. So there's like a public concern that the government might have some sort of like more authority and might misuse the power. So I just want to ask your opinion on this and how do we go from this? My name is Haikal.
Anyone else?
Thank you, sir. Thanks for your discussion. Mike, you mentioned towards the end on the responsibility of the ISP, right? They might redirect. So that took me to the thought of phishing. And then that took me to DNS abuse and the recent contractual obligations that came for registries and registrars. So just want to understand, like I very briefly went through it, but I just want to know under what situations does, a registry or registrar, can we push for a takedown of a domain, and what situations are escalated to ICANN? As in, what are the obligations of a registry or registrar situations? And yeah, yes.
So I've got 2 questions. One, when I analyze 100 websites in India of .in, I see roughly around 9 to 10% of them are DNSSEC signed. Okay. So what does this data mean, and what is the reason for people not deploying it? It is just lethargy or unawareness, or what can be done to increase this one?
Okay.
And the second is a little more future looking question, that what is going to be the when unstoppable domains kind of things comes, what is the future of DNS itself?
Okay. Let's get to Aishwarya. Yeah. You mentioned about the performance. Yes, there will be some performance issues. When you deploy DNSSEC, as I said before, you are dealing with cryptography. So you have to say earlier. I mean, I will take a very simple example. Say, I am a domain holder. So I have my DNS zone file or the database. Say I have 5 records. Now earlier I only had 5 records. Now when I deploy DNSSEC, which means when I sign all those records, those say earlier, I mean, for example's sake, let's say each record is 1 kilobyte, right? Just for example. So 5 records means 5 kilobytes, right? So once I sign my zone, suddenly this 5 kilobytes will become like 50 kilobytes. Why? Because every record is going to have an associated signature. Because after signing, I will have a signature associated with every record. Not only the signatures, but I also have to include my public keys into my zone. Because if anyone want to verify my signatures, they have to have my public keys. So I have to publish my public keys, I have to publish my signatures. So when you add all those, so 1 kilobyte will become 5 kilobytes for every record. So which means, I might have a 25 kilobytes file or more than that, much bigger zone file I'm going to have, right? So from zone owner's perspective, definitely when you have, when say for example, if you have million domain names, right, in your zone. I mean, as I said earlier, .com has 135 million domains. So it's a huge zone, right? So when you have all those signatures in your zone, definitely there will be some performance factor there. So you have to do some capacity planning before you do that signing. And also that will include things like when you do the signing, because there are lots of things will come into the picture. What keys that you're going to use, right? What key algorithms you're going to use? How many bits, what is the size of this key? Is it going to be a small key or is it going to be a strong key? What should be the size? So all those factors will contribute to the performance aspect. So you have to do some sort of analysis before you really go and sign your zone. What sort of performance factor that you have to handle, right? So that has to be done in the capacity planning beforehand. Now from validation aspect, also there will be some performance matters. Say now if I take the role of a ISP resolver, right? Say I'm ISP resolver. Now earlier I only got web server IP address. That's it, right? Earlier, the server gave me the name and the IP address. Right? That's it. But now, so if I'm a resolver.
Running out of time as well, so probably we can take a couple of questions.
All right. Okay. Sure. Okay. All right. So yeah, to answer your question, there will be some performance matters. Even to do the validation, because of those signatures. Earlier, I was only getting the without the signatures, but now I'm getting with the signatures. That means I have to do validation whether these signatures are correct. So this validation will have resource constraints. So there will be some performance matters that will come into the picture. So you need to actually handle those beforehand before you really deploy or enable DNSSEC. Okay. Now going into the registry. Yeah. So now ICANN has got contracted parties. So all the generic top-level domains, they have contracts with ICANN. And also there are registrars who are ICANN accredited registrars who are having contracts with ICANN. So we call those as contracted parties. Now, say if you experience some DNS abuse, your first point of contact would be the appropriate registrar, right? Because in DNS you have this administrative structure where you have the registries, then you have registrars, and then you have in some countries they have resellers, and then you have so if there are some abuses, first point of contact would be registrar. So you can usually, if it's a good sort of registrar who are practicing the best practices, they should be actually providing you the information how such abuse matter should be handled, what email ID the abuse complaint should be made to, and things like that. So this is what we call the acceptable user policy. Whoever, they should publish this AUP, the acceptable user policy. So based on that, you can lodge the abuse complaint. But if the registrar is not taking any action, you could escalate that to the registry operator. Now, if the registry operator also actually not responding you or something like that, this is where you can come to ICANN, because ICANN has got compliance division. So you can get to ICANN compliance, and especially if they are ICANN accredited registrar, as I said before, or ICANN registry operator, the contracted party, then you can lodge an compliance matter with ICANN as well. So that's how the escalation path is. I think coming back to that Malaysia thing, again, you can look at it from two sides. First of all, you were actually explaining about the DNS redirections, right? So when I send a DNS query, basically, all my queries are being taken, and whoever the regulator or whoever, take a decision how to handle the DNS query. Different other server, or send it to the appropriate client. Now, again, this is of course, a regulatory decision, but there are two aspects. One is that sometimes it could be, it is good that they do that, mainly because unknowingly people could go into things like malware sites and so on, right? Because if there are some abusers threats, as I said, there are quite a lot of security issues, so you can go into wrong places. So if there is some sort of mechanism to do some redirection, it can go to proper places. But at the same time, there are privacy issues that you mentioned before. If they are going to use your DNS data, what we call the metadata, and then send all this DNS query to, based on your metadata. So if you want to actually monitor which websites that I'm going to, or what are the frequent visits that I do, and things like that. Based on that, if they want to take some decisions, that's against your privacy. So this is where you have to think of DNS encryption. So there are different protocols that you could do DNS encryption, right? So there are two aspects to that. Okay.
I think we are seriously short on time here, so I think we can take that question offline if it's okay with you. So, ladies and gentlemen, thank you so much for your patient listening, and thank you so much, Ampika, for detailing out a lot of details, right from the beginning of the development of DNSs and all the way into the future. Thank you so much, and that was really nice learning from the horse's mouth. Thank you so much, ladies and gentlemen.